Hi, Mrs. France here, and today we are going to jump into more decimal work, but now we are comparing and rounding. So there's multiple ways we can do that, but the main aspect is that we are going to be using place value in order to see how decimals might round to a certain place value or how to compare their values with one another. We'll even do a little bit of ordering of these numbers as well. So the first thing we want to make sure we feel really comfortable with is number one, number lines. And seeing these values on a number line can easily help us compare and to round. So we are going to first discuss looking at parts of wholes on a number line. So you can see on my number line here, I start with a 2 wholes and it goes all the way to the next hole, which is a 3. So when we are looking at parts of a whole, it could be between any two whole numbers. So parts of a whole could be cut into many pieces. For this one, we're going to be looking at cutting it into tenths. That means there's how many pieces in this whole if it's cut into tenths. So you should have said it's cut into 10 pieces because if there are tenths, each chunk is a tenth, one out of 10. So in order to think about this, we can first by cutting it into 2. So if I cut my whole into 2, you can see that this is how much of the whole? Yeah, it's a half. So if that's a half and this is a half, we now have 1 out of 2, but we need it to be 10. So I'm going to cut this, and half of 10 is 5. So when I go to cut this, I have 1 piece, 2 piece, 3 piece, 4 pieces, 5 to get to that halfway mark, okay? When we count our number line, we're not counting the dashes, they're the cuts, 1, 2, 3, 4. I only did 4 cuts. We're counting the pieces in between. So think of like a candy bar and having a chunk of it. 1, 2, 3, 4, 5. See that? So then to get to 10, I'll need to do 1, 2, 3, 4. Common mistake is if you count your cuts, you won't have enough or you'll have too many. So now let's see. Am I in tenths? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, when we're looking at parts of a whole, all the parts should be equal. Now, doing this freehand, we're not measuring and checking to see that they're equal, but it's a concept we should understand that parts of a whole are all the same. So all of these pieces are equal in size. So let's go ahead and start thinking about the values on this number line with tenths. So if the total is tenths, this would be 1 out of 10. So looking at it total, we can record down that this is 2 and 1/10, okay? So sometimes this looks like a 21, but remember, this is a part of a whole. And we already have 2 wholes, so you can see that those zeros can count on to make into 3. So then this would be 2 and 2/10. This would be 2 and 3/10, 2 and 4/10, 2 and 5/10, 2 and 6/10. So because it is 6 out of 10, 6/10. We did some of that kind of thinking when we were making our expanded form in fraction form with our decimals. So then we get to our 3, but of course we can also look at the 3 wholes being a 3, the decimal, and a 0. And then you can kind of see how these count on and up by tenths, right? So the other aspect we want to look at with our number line is that every single decimal has an equivalent fraction. So when we were doing our expanded form, we not only did our expanded forms in fraction version, but also decimal version. So here, select different colors to see the difference. 1/10 would be written 2 and 1/10. So it has that equivalent version. And then, of course, 2 wholes is still just 2 wholes. And then 2 and 2/10. Yes, some fractions can be simplified. Any fraction experts out there of what this would be simplified to? This was a 4th grade concept, but it's always sometimes a little new coming back to 5th grade. So 2 and 2/10, what would that simplify to all the way? Good, it's 2 and 1/5. So this one, 2 and 3/10, 2 and 4/10. Now 2 and 5/10 is 2 and 5 over 10, but we also know that one commonly as 2 1/2. 2 and 6/10, and you can see the pattern go on, but the tenths is what is changing. 2 and 8/10 and 2 and 9/10, and then of course just 8/3. So here we are counting in tenths. So if I said we're going to compare 2 and 3/10 to 2 and 6/10, we can easily see which one's smaller, which one's larger, and by how much, even if we wanted to get into that. So number lines, parts of a whole, cut into tenths. So what about hundreds? So thinking of hundreds, if we think of our decimal, this place value is tenths, and then this place value is what? Hundreds, right? And sometimes we'll have a whole number as well, and we have that here. So we're starting with 4 and 2/10, and we're going all the way to 4 and 3/10. So when we look at this, how can there be something in between 4 and 2/10? After 2 should be 3. So when we cut this, we're going to look at even smaller cuts within cuts. So back into tens, it's like what we're doing now with hundreds is we're zooming in to one chunk and making it bigger and looking at it. So all the pieces that are within here, okay? So all of these are going to be 4.2, 4.2, 4.2, 4.2, but adding on hundreds to it. So it would be 4 and 2/10, but then keep counting on with the hundreds because we're cutting parts of parts, okay? So when we cut this, we are not going to cut it into 100 pieces. It's within the 100, this tenth to a tenth, that we're going to cut it into another 10. Kind of like our place value system. So we know that if we cut this in half, we would, like I said, still be at a 4 and 2/10 because all of these are going to have a 2 in the 10 spot. It's the hundreds that's going to count on. So if I'm halfway, let's think about this. What place value do you think, now I know this could be tricky, what place or what digit could be in this place value if I'm counting halfway? Now I'm going to give you a little tip here. Couldn't you think of this 4 and 2/10? Isn't it the same thing as 4 and 20 hundredths? And isn't this the same as 4 and 30 hundredths? Can you see it now? It's like counting by ones. If you just disregard the whole number, what would go here then? 4 and what? Yeah, 25 hundredths. Did you see it? So then now it's like counting by into cutting it into 10, just like we did before. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So let's look at these values and how they would change, okay? So we would have 4 and 21. See how it's counting up in the hundreds, 4 and 22 hundredths. 4 and 23 hundredths, 4 and 24 hundredths, the 4 and 25 hundredths, 4 and 26 hundredths, 4 and 27, 4 and 28, 4 and 29, and then we get to our third. Now remember, 4 and 3/10 is the same thing. It's equal to 4 and 30 hundredths. That zero just makes us see it differently, like we did with last lesson, reading decimals. But now that we have that zero there, we can kind of see how these hundredths are parts of a part, okay? So from here, I want to explore the idea of, well, what if there was a thousands, right? So can I even think about that thousands place and look at parts within this part, parts within a parts within parts, right? So we can keep splitting these up and thinking about them that way and find their equivalent form. So for example, if we were looking at these, you could say, just like we did before, that we had 4 and 2/10. But then how would that be in hundredths to compare it to all of these? It would be 4 and 2, not 2, but 20, right? Because that 2 is in the tens, but we're looking at all the way to the hundredths. So you have to say 20, and then it would be hundredths. Those are equivalent. You can kind of see it almost, sometimes the trick is just looking at adding zeros so that you can see it all the way to that place value. So this would be 4 and 3/10. And what fraction would it be then? Thinking of what we did here, 2/10 became 20 hundredths. What would this one be? So it would be 30 hundredths. You have those equivalent pieces. So let's try this one. How would you write this one as a fraction? We would have 4, and your numerator would be 25. What would your denominator be? Hundredths. Okay? So sometimes we need to look at these values being the same so that we can compare them, right? So let's put some of this into practice. Looking at Gary and Melissa, they're comparing the distance they walk each morning to get to school. So Gary walks 3 and 235 thousandths kilometer, and Melissa walks 3 and 24 hundredths. Now, something that we need to make sure we recognize is we're used to working in a world of whole numbers more often than not. Now that we're in the world of decimals, we need to think about the size and how many digits there are doesn't mean it's a bigger number. So just because there's more digits doesn't always mean it's bigger. When we are in whole numbers, the more digits you'd add on, the higher the place value. So the larger the number. But look at the digits in their place value and how much does that place value actually, how much is it worth, is what we're really going to need to analyze here. So just glancing at the numbers isn't always the way to go. So we have 2 different ways, actually 3 different ways we can model this. So the first way is mixed numbers with like denominators. So going back to thinking about changing decimals into fractions, but being the same amount of pieces in denominators in order to compare them. So when we look at this, I'm going to say, okay, I have Gary and I have Melissa. And Gary did his walk for 3 and 235 thousandths. Remember, if you read it like a mathematician, you have your fraction. So I'm going to go ahead and write that one. That equals 3 and then 235 over what? 1,000. Make sure you have the correct amount of zeros. And then, so for Melissa, when we write this one, we say what? 3 and 24 hundredths. We can't compare those right now. We can't compare them because they are not cut into the same amount of pieces. That would be like having someone come in and say, oh my gosh, I ate all of the pizza and it was, or I had 2 pieces of the pizza and it was only cut into 2. That's the whole thing. So your size of your pieces matter when you're comparing them. Because if I had a pizza that was cut into 100 slices and I had 2, my pizza slices would be smaller. So depending on how many cuts of a whole would depend on the size of your pieces, right? So this being a 24 right now, 24 what? Hundredths, we can't compare. So we need to do like what we just looked at and explored with the number line, and we need to put on our zeros. Technically, it's like we're multiplying it by 10 to then be able to compare thousands to thousands, okay? You'll notice what looked like it was smaller, 24 versus a 235. It's actually, when we get them in the same amount of pieces, it's 240, 235. So who walked farther? Yeah, Melissa. Okay. Well, maybe putting them in fraction form isn't the best way. Maybe this is a little fuzzy still. We'll keep practicing it, but let's look at some other ways you can look at these values and be able to compare them. This is one of my favorites, and it's just lining them up by place value. So if I look at Gary's and his, I'm just going to be real precise here when I line them up. I'm going to think about all my place values being together. Kind of like when we add and subtract whole numbers, we have all the place values lined up, so we're subtracting and adding from the same place values. I'm lining them up like that. So one key factor of knowing that they're lined up is my decimals are right on top of each other. Because otherwise, if my decimals are in a different spot than one another, I know my place values are not the same directly above one another. So when we compare these, okay, they both have a 3. They both have a 2. Now, if it's a tie, we keep moving to our values to the right. And so those are the same. I always like to circle where there's a difference. So if it's 3 and 2/10 are the same, it's not until the 100th spot that they're different. So I can see that the 3 versus the 4, which one's greater? Yep, Melissa still. Now you might go, well, wait, there's a 5. 5 has some value. But what place value is this in? It's in the thousands. This is such a smaller value than 4/10 that just because there's more digits doesn't mean it's larger. This is just a smaller value, even than that 0, okay? Because 40 versus 35. Do you see that? So lining them up, making them into fractions, but they have to be common denominators. And one other way is looking at it on a number line. Number lines are really great for quickly seeing all the values at once, but they're kind of time consuming to make. So our focus isn't here to actually make these beautiful number lines, but to just be able to use them and function with them. So I already have you started. It's starting with our 3 and 2300ths, and it's going to 3 and 2400ths. So, when we're counting on by hundreds, 23 to 24, well, it looks like we're breaking this up by thousands. So when we break this up by thousands, we're going to keep adding on to that thousands place value. So I always like to put that 0 there, so I'm looking and thinking about counting on by 1,000. Otherwise, it feels like I'm missing some digits, right? So I'm going to go ahead, and I always like to start with halfway, and that's because I'm thinking 230 to 240. What's halfway? So it would be 3 and 235 thousandths would be that halfway mark. And then, so now I can do my cuts of 10 to get to 10 total pieces. okay? Now I'm going to fill in all of the different amounts on each line. So voila, my number line is done. We counted by 1,000, so 231, 232, 233, 234, and so on all the way to get to 240. So really looking at where are these values on this number line. So when we look at our values that we have, Gary is 3 and 235. Okay, well, 3 and 235 is right on the number line. So I'm going to plot a point on the number line, and I'm going to label it a G to show, okay, this is where Gary's at. Now, where's Melissa's? So we're working only with tenths here, and we actually have that on the number line. Or I'm sorry, tenths, and it goes all the way to hundredths. So right here we have that, and there's Melissa's. So can you easily see on a number line that Melissa definitely went further? So when we're talking about greater than, less than, equal to, we can write an inequality statement. So is it equal? Is it not equal? And which one is it, greater than or less than? So quick review, our greater than symbol always goes to the right, less than symbol goes to the left, less than left. That could help. And I know there's other ways that you can think about it. Is a lot of students come to 5th grade thinking about eating the bigger number, and then of course the equal sign. So an inequality statement is always going to start with a number. And so I'm going to go with what we started with. We had Gary here, 3 and 235 thousandths. And we leave a space for one of our inequality signs. And so I'm going to leave some space just so we can talk about this. And so we said Gary's is greater than, less than, or equal to Melissa's. So Gary's is actually less than, we found. So I'm going to use my less than sign. Now these statements read like a sentence. So when I read it, I can say 3 and 235 thousandths is less than 3 and 24 hundredths. Okay, and multiple different ways to think about it. So think about which one you like and which one works well for you. Now you still need to be able to function with reading it from a number line and making them into fractions, but ultimately for future use, you can kind of pick your own if it's just asking for an inequality statement. So now let's look at rounding. We've looked at how we can compare these values if they're decimals. How can we look at them if we are rounding? Now rounding is very similar to estimating. It can get confused with that. So if I go to the store and Oreos, sound good, right? Oreos cost, let's say, $3.25. If I'm saying, oh, that's about $3, right? I'm thinking of that 25 cents and going, okay, is that really close to being $4 or $3? So that's estimating, but I'm technically rounding it to the nearest whole dollar to think about these values. So rounding is just another way to estimate and think about these values in a very simple way. And it's one of the biggest things that we use in our daily life and as adults is that we think about things instead of trying to find a true answer or calculating, we are using estimated rounded answers a lot. So for this particular question, we have Mara has a shelf that is 2 and 97 hundredths of a meter long. She's buying boxes that are 273 thousandths of a meter long. Mara wants to round these numbers to the nearest 10th to estimate how many boxes will fit on the shelf. So she has this shelf and she wants to figure out how many boxes can fit, right? So makes sense. Can you imagine setting up a store and the trial and error you would do if you didn't think about this? You would be just trying to fit all these boxes and you might not have the right amount of space or the right amount of shelves. So this is a smart real world thing to do. So we need to figure about how many boxes. Since we're estimating, since we're rounding, for this estimate, we're not going to get an exact answer. So we will always have the about how many boxes will fit. So let's round these shelves to the nearest 10, like it asked, using a number line. So I have my shelf number line, and then I have my box number line. What you can see is what they start with is different because the values are, of course, different. This is going to the hundreds, and this is going to the thousands. So I'm starting with 2 tens for my shelf and going to 3 tens because I am going to look at the hundreds in between. Okay? So when I do that, I'm going to see that this is very similar to just looking at it as a 20, and this is a 30. And when you do that, you can really see what these little parts are going to be in between. So I always like to start with my middle, 1, 2, 3, 4. So 1, 2, 3, 4, 5. So I know this is going to be a 25 hundredths. And then I can see that this is a 21, 22, 23 hundredths, 24 hundredths, 25 hundredths, 26, oops, there we go, 26 hundredths, 27 hundredths, 28 hundredths. Oh, I see what I did there. Careful counting. 26 hundredths, 27 hundredths, 28 hundredths, 29 hundredths. So when looking at the shelf and we have 97, how can we 2 and 97 hundredths? Where could this be on our number line? So if we look at our boxes are 2 and 73 thousandths, but we have just hundreds. So remember, we can look at parts within parts. So if you even think about this as these having zeros, you can kind of see where that 73 would fall. It would fall in between the 27 and the 28. Do you see it now? So I can think about this as being, well, if about halfway is 75, well, then it's about right here, right? So if we're rounding it to the nearest 10, is it closer to the 2 tenths or is it closer to the 3 tenths? If our shelf is right here, which tenth is it closer to? Yeah, it's definitely closer to the 3 tenths. So for the box, now we are going to be plotting, the box is, that's the shelf, and the box is 2 and 97 hundredths. But again, we're rounding it to the nearest tenth. So I started with my tenths. Options are 9, and then after 9 would make the next place value go up. So it technically could go to a 3. Okay? So looking at these parts within parts, 2 and 91, 2 and 92, 2 and 93, 2 and 94, 2 and 95. There's my halfway part. And 296, 297, 298, and 299. Made it all the way to 3 holes. So rounding to the nearest 10, where is this original amount, the 2 and 97? It's there. And we can see it right on the number line. It's right here. So we didn't even have to look in between like we did with the shelf. So for the box, which tenth is it closer to? Yeah, definitely the three holes here. Okay. So now we can look at rounding the shelves to the nearest tenth using place value, right? So place value, we can just line up the numbers like we did before. So if I have my shelf being 273 thousandths, I can see that if I'm rounding to the 10th, I always like to underline the place line I'm rounding to. And if I look to the right, I can see that this 7 is going to make it go up. It's going to go make the 10th place go up because it's past halfway. You can see that on a number line. If it's past halfway, it always rounds up because it's closer to the next one. So then that would equal a 3/10. And for my box being 2 and 97/100ths, I'm rounding to the tenths place again. So I look to the right, and that's past halfway, so it's going to round up to the 3 wholes, right? So to the nearest tenth, how long is the shelf? We have 3/10, and then we have how big is the box? 3 wholes. And so if you think of your powers of 10, how many of these would it take to get to this one? So think about it as an equation. We have 3/10. How many is it going to take to get to 3? Powers of 10? Yeah, 10 of them. We can put 10 boxes on the shelf. And always big labeling so we know what we're talking about value-wise. 10 boxes. All right, so we are going to continue practicing our rounding and comparing using those strategies. All right, good luck.